So, question 15 is a cumulative frequency graph, and it says the cumulative frequency graph shows a cholesterol level of 50 meat eaters. And part A cholesterol level over 5.5 is considered high. Work out an estimate of the percentage of the population that have a high cholesterol level. Now, the fact that the word over is in bold means we need to make sure we read that part of the question carefully. So, cholesterol level of 5.5, you just go to the graph, and here's 5.5 between 5 and 6. You would use your ruler, you would read up, you'd have to be super accurate. It's kind of halfway between those two squares. So I would say it's hitting about there. And then you would read off across. And again, you'd use your ruler to draw this in. And if I'm reading that off across using this scale, it's 35, 36, 37, 38. About 38 is the number that I would pick. However, it's saying a cholesterol level over 5.5 is considered high. Now, the 38 are all these people that are below 5.5. So we actually need the difference between 50 and 38, which is 12 people. But 12 people out of 50 is not a percentage. So we need to turn 12 out of 50 into a percentage by doubling the numerator and denominator. So that becomes 24 out of 100, so 24%. But that would be based off the value that you read on your graph, and there's always a little margin for error, which is about half a square's worth. Now, in part B, we are told we have a box plot for vegetarians. So I'll be going back to the previous graph because we need to do a comparison of the box plot data and the cumulative frequency data. 50 vegetarians also had their cholesterol level tested. The box plot shows the results. Okay, it says using the median and interquartile range, compare the cholesterol levels of meat eaters and vegetarians. So the first thing that I'm going to do is I'm going to write down some numbers, because if we're doing a comparison, we need to quote numbers. We need to then use those numbers and explain what it means. And nobody particularly answered this question very well. So I'm going to put median, I'm going to put interquartile range, I'm going to do my vegetarians, and then I'll have to go back to my cumulative frequency graph to work out these values for the meat eaters. So remember, on a box plot, this number, this line, is your median. And that, each little square is worth 0.2, is 4.8. The interquartile range is the difference between this value and this value. So this is 5.2, take away 4, which is an interquartile range of 1.2. So let's go back and have a look at the cumulative frequency graph. So remember, this is 50 people. So the median is at 25. So reading that across, reading that down, that looks to be about 5 and not even one little square, half of the square. Well, that will be 5.1. Okay, so 5.1 is the median for the meat eaters. Just going back and get the interquartile range. So the interquartile is between a quarter of 50, which is 12.5. So again, I'll read that off in a minute. And 37.5. Well, that's practically the value that I've just read off there. So the interquartile range is going from 4.8 to about 5.5. Maybe a little bit less, maybe 5.4. Okay, so that is a difference of 0.6. So I can now write in 0.6 was the interquartile range for the meat eaters. Okay, now, so when you're doing a comparison, we must use these numbers and explain what it means. So have a look at the cholesterol level, the median cholesterol level for the meat eaters. Okay, the median for the meat eaters is higher. Okay, and that is 5.1 compared to 4.8. But even better, explain what that means. Well, the median's a type of average. On average, cholesterol is higher for meat eaters. Okay, and that would get you 1 mark. So compare the numbers, explain what it means. Okay, now let's look at the interquartile ranges. Well, that is smaller for the meat eaters. So the interquartile range is smaller for the meat eaters. And there was a word that we used when the interquartile range was smaller. It means that that data is more consistent. So the interquartile range is smaller for the meat eaters, so their cholesterol levels are more consistent. And more consistent just means similar, more consistent. Question 16 was a histogram question. In order to answer a histogram question carefully, we've got a very important formula we need to remember, which is frequency density is frequency divided by class width. And we did a lot of questions like this. This is a very, very typical exam question where you've got half the table, half the graph, and it says complete the table and the histogram. So what we need to do is work out our frequency densities for the data that we've already got. So this frequency density would be 120, the frequency, and the class width is 30, so 120 divided by 30 is 4. I can work out these ones as well whilst I'm here. This is 180, that class width is 20, 180 divided by 20 is 9. And this one is 140 to 180, the class width is 40. So we've got 80 divided by 40, which is 2. So how does this help us out? Well, now we can work out what this scale is, because this 60 to 90 is this bar here. So that tells me that this height on this scale is 4 there. And just having a quick look, that means that every 5 little squares must be worth 2. So 2, 4, 6, 8, 10. Now, to get these numbers here, we can read off the height of these bars. The frequency density must be 6, and the frequency density of this bar, 110 to 120, is 10. Now, to get our frequencies, we now just need to do the frequency density times the class width. So 6 times 20 is 120. And another thing we can see is the area of those bars looks the same. Hence why this number is the same. And then we've got 10 times 10. So that one is 100. But we're not quite finished, because we have to finish the histogram as well. We need to draw these last 2 bars in. So you'd use your ruler. Between 120 and 140, we need a height of 9. Sorry, I'm doing this in the wrong place. So 120 to 140, we need a bar of height 9. And 9 is slap bang between 8 and 10. So about 2.5 of those little squares. And then we've got a bar that needs to be 2 high from 140 to 180. So that is that question completed. But the key is this formula here. So make sure you get that formula learnt, please. And finally, the last question, question 17. Part A is difficult, but we're going to have some difficult questions in for set 2 and set 1. Part B should have been fine if you read the question again carefully. So it's the whole idea of reading questions super carefully. So let me go through the answer to part A, and then we'll go through the answer to part B. So the quadratic shown is symmetrical about the line x equals -2, and that is super important. D is the reflection of A in the line of symmetry. Write down the coordinates D. Now, if you think about it, D must go along the x-axis so far and up the y-axis so far, but the y-axis value must be exactly the same. Okay, because of the symmetry, it is the same distance up the y-axis, so that must be 16. So in this coordinate, it is also 16. Slightly trickier though is working out the x coordinate. Now, this is where the line of symmetry comes in. If the x value is 3 along the corridor, then to the line of symmetry, that is 5 units along the x-axis. So we must go out 5 more units to work out the x coordinate of D. So count back from -2 5 places, it must be -7, 16. Okay, now in question B, you probably saw me underline it. It says, what words best describe point B? So immediately this is implying there is more than one answer to this question. It also says circle your answers. Again, it's plural, so it is implying there's more than one answer. And the answer to this question, well, we've used all of these words, okay? It is a turning point. And at the bottom of a curve, it is a minimum. A point of inflection, we did mention in passing, is where it turns and it starts changing its mind. A maximum is like an N-shaped graph, and a root are the solutions to the quadratic equation, which is where it crosses the x-axis. So minimum and turning point.